This is Comp 621 Web Security once again. And today we're talking about cross-site request forgery, CSRF. We're in looking at cross-site request forgery, I learned that it really is important that everybody understand exactly how cookies work. So I've got a little bit to review how cookies work. We talked about it before, but I wanted to go over them with a little bit more detail. So we'll talk about cookies. And somewhere along the way, we'll also talk about the exam from last week. Hopefully everybody's had a chance to look at their scores on Blackboard. Okay, so let's take a look at the cookie stuff. Unless anybody has any introductory questions. Nope. Okay, everybody ready to roll? Then let's take a look at that stuff. Oh, okay. Yeah. Okay. Yes, at last. Cookies. We're going to talk about cookies. I had lots of fun making these slides. Okay. What's a cookie? Cookies, a bunch of bytes that it sends in the HTTP header from a server to the browser. And then the browser sends it back to that server whenever it interacts with the same server. It will not send it to different servers, but if you go back to the same server, it will send the same cookie that it got from the browser. Here's how you might look at it. Okay, browser goes out to look at a web page. You click on a link or you type in a URL and it goes out and that web page says, oh, okay, and it sends you the information you requested. And in the HTTP header, it adds a cookie or not. By the way, cookies are not required. They're just optional. But it may send you a cookie, in which case the browser will save that cookie. And then if you go out to that website again, it will send the very same cookie back. And then the server will know that this is somebody had seen before because it'll get the same cookie back. Typically, cookies are unique for each user and each invocation. Okay, now there's a reason we have cookies. In general, web servers and API servers are stateless. That is, they don't really save information about continuing sessions. Each request is independent. So if you go to the web server and you request a page, and you go back and request a different page, unless the server does something, and something is cookies, it doesn't know who's going to what page, or even cares. But sometimes you do care. Sometimes you want to do things in progression. In other words, you want to know, did this user log in before I show them this information? So you have to know about the previous accesses to this web server. To do that, they can use cookies. They can put, the server can send a cookie back to the user when you sign on, and then the user will send it back to the client. And it can save various information in the cookies. Now, when you write a program on the server, say PHP or Java, it'll talk about session information. The session information is related to the cookie. Either it is the cookie or the server keeps a simple database of the session information, which is keyed by the server session ID stored in the cookie, or is the cookie. Now, what can you put in the cookie? You can put all sorts of things in the cookie. Often the cookie is simply a number, a large number, often a hexadecimal. And then when the server receives that large number back, it uses it as a key to find the information it wants. But it can put lots more information in the cookie. We'll cover this in more detail later, but you can put the user's names, what the user's been doing, what pages did they visit, where they've been clicking. And of course, information from forms. What have you entered before so we know what you can enter again? And geographical information. I've been looking at cookies in the last week, and I was amazed to learn that Wikipedia knows my city, my latitude and longitude, where I'm located in the universe. And so that's in the cookie. Now, there are different types of cookies. In particular, there are session cookies and persistent cookies. A session cookie is temporary. It only lasts for that session or for that one connection with the server. In other words, you might go to multiple pages, but until you log off, you've got the session cookie. And as soon as you terminate the browser, it deletes all the session cookies. So they're not saved in mass storage. They're simply saved in the browser's RAM storage, and they go away. Now you can tell, how do you know a session cookie when you see one? They do not have an expiration date. Any cookie without an expiration date is a session cookie. Now, in the material I've read, they claim that session cookies can be safer because they go away. So opposed to a session cookie or a temporary cookie is a persistent cookie. Persistent cookies are stored in the file system on the client machine, or as the browser stores this in its mass storage and then can keep it forever and ever. Persistent cookies have an expiration date. They have an expires clause, and that says when this cookie is supposed to expire. When the cookie expires, they throw it out. It's no longer supposed to be deleted. There's also, if you look in the example we see down here, let's see if we can't be good about doing this. Oh, let's try, yes, nope, well, that's not. There we go, all right. Hopefully you can see this. There's in the example, this is an example I got from insomniacookie.com. There's an expires, and that specifies when the cookie is supposed to, and it'll be useful until that date. It also gives a max age parameter. They're about the same thing. In fact, they are pretty much identical, except max age gives you the number of seconds until this cookie is supposed to expire. So if you have a max age of 3,600 seconds, that would be 1 hour. So the cookie is good for an hour. And so I probably got this cookie on February 18th at 17:15 GMT, probably middle of the afternoon. And it was good for an hour or good to that time. So that's the expiration date on the cookie. Sometimes, sometimes a persistent cookie can be thought of as a tracking cookie, because since they persist and the browser will see it over and over again, it knows when you were last there, what you've been doing. Okay, if we look at this cookie, we'll also be looking at this later. Okay. There are several options a cookie can have. And all the options, well, yeah, most of the options are a name equals value pair. So you have some sort of identifying name, and you can make up any name when you're creating the cookie on the server side. You can make up any name you want to, and then set the cookie value to that name, and it will come across as the cookie's name equals and then the value in a semicolon. If you look at the previous example here, the cookie is called insomnia_cookie, and I shrunk it here because it was rather lengthy, but there it is. And it is probably base 64 encoded. You can typically tell it's base 64 encoded if it consists of upper and lowercase numbers, or excuse me, upper and lowercase letters, numbers, and maybe a minus sign and a slash. Those are the base 64 values. Okay. All right. Other things you'll see in there are secure. Secure, which by the way doesn't have, secure and HTTP only don't have values. They're just a statement. Secure says this cookie can only be sent over HTTPS, the encrypted version of HTTP. You can't send it over a regular HTTP connection because then some other system may be able to see what it is. So only send this cookie over HTTPS. So if a server sends a cookie to a browser with the tag secure, then it must use HTTPS. Again, you can see over here, this cookie has a secure. It also has HTTP only. HTTP only means that this cookie cannot be accessed by JavaScript. If you remember, you can go document.cookie to get the cookies. And you can look at all the cookies in your JavaScript, unless somebody uses HTTP only, and you can't see that cookie in JavaScript, which might be good if you don't want somebody messing with your cookies. There are other parameters. One of them is path. Where should we put this cookie? And that refers to the cookies for this server. And typically you see path equals / which means the root directory of the cookies for this server. Although sometimes on a big site, they may separate the cookies into groups. Another one is domain. What domains, or actually subdomains of this domain, can use the cookie? Now, the domain has to be the domain where the source of the cookie came from. So here, again, I got this from insomniacookies.com, but it could be used at www.insomniacookies.com or catalog.insomniacookies.com or anything that ends in insomniacookies.com. By the way, you'll often see a leading period to the domain name. Once upon a time, the standard said you had to have a leading period. Now it doesn't, but you'll see it there all. Okay, so this says, in any site that ends in insomniacookies.com, this cookie can be sent, but don't send it anyplace else. Okay. Another very useful option, particularly for avoiding cross-site request forgeries, is the same site option. And same site option can be set to 3 values. You can go same site equals strict, or equals lax, or equals none, or don't put it there at all. Strict means this cookie is only going to be sent to the same site that sent you the cookie. In other words, you're not going anyplace else. Now, lax is similar, but if you have a link coming in from some others that goes to this site, it will use the cookie. An example that they had, something I read, that imagine you're on GitHub looking at one project, and you get an email from your company, a legitimate email that has a link to a legitimate GitHub project on GitHub, of course. It's a different project. So you click on that one and you go to that website. Well, now that is a different connection. If it's strict, the second one will not use the same cookies, and you'll have to log into GitHub when you click on it from the email that you got from your colleague. If it's lax, though, it would use the cookie. And therefore, because you are already logged into GitHub, you could remain logged in and go to the other project. Of course, if you say same site equals none, it says, who cares? We'll just send the cookies any place you feel like. That obviously has some security implications. The option was introduced by Google a few years ago. It's starting to become implemented here and there. And interestingly enough, the biggest concern about it, everybody thinks it's a good thing to reduce cross-site request forgeries, but the question is, what do you do if a cookie doesn't have this parameter? Well, Google thinks if you don't have the parameter, it means none. Other people think, well, maybe it should be lax. And so that's the biggest concern, is what does it mean if this is not there? Now, there are other types of cookies you can have. I found these interesting, so I included them. There's the zombie cookie. The zombie cookie is recreated if it's deleted. If something deletes the cookie, don't worry, it'll come back to life. And sometimes cookies are involved in other applications. For instance, PDF, Adobe PDF, it might store the cookies there. If the browser cookie is deleted, it can get it off the Adobe PDF. In other words, typically this involves cookies that are stored in multiple locations. If one of them is killed, pick it up from the other location. You have to be thorough in killing a zombie cookie. And then there are super cookies. Now we saw that cookies can have the domain. Backing up, there's the domain. But what if it just said domain equals .com? Well, that's a pretty broad decision. And that would make it a super cookie, allowing you to access that cookie in any top level domain. That would be a security problem. And so most browsers block super cookies. Okay, now you have third-party cookies, which are a significant concern. We'll talk about those in some detail. First of all, a first-party cookie is one that you get from the site in the address bar. In other words, if you type in www.acme.com and you get a cookie from acme.com, then that's a first-party cookie. But you might get cookies from someplace else. A lot of web pages will have images or text or other information from other websites. It's just not uncommon to have pictures that are not stored on the server in the address bar, but on some other server. And also advertising. You may just have noticed advertising in a few web pages, just perhaps. Here is a screenshot I took off my wife's computer because she looks at a lot of stuff that I would never touch. Yes, you can see all sorts of advertising. The advertisement here, and then an advertisement here, an advertisement here. And it's interesting to note, yes, this is about a card with flags. My wife is a vexillologist, a studier of flags. And so she looked at cards with flags, and suddenly she gets advertisements for more cards with flags. She looked at something for Darn Good Yarn, and now they've got her. Go out there and somebody gives her an ad for Darn Good Yarn. So she read something in the New York Times. Ooh, do you want to subscribe? Well, how do they know it's you? Because the cookies. Okay, let's look at this. So you go out to acme.com, and the page, like the one we just saw, has links to all those pictures, all go out. So you say the pictures come from adguy.com. So it sends a request to adguy.com. It's an image, the source equals adguy.com, sends out a request, and then adguy, and then to do that, though, it sends a cookie. Now, if it's been to adguy.com before, and my goodness, it certainly has, then it's going to send the adguy.com cookie along with it, with the request. And so you go out there and adguy.com goes to that. So if you go to another website, so you go to other.com, and that also has ads from adguy.com, it will send all the adguy.com cookies it has. So now adguy.com knows, oh, this is you, and you've been looking, you were over at this other site. So yes, you were at this other site looking at Darn Good Yarn. It remembered that. Oh, you were looking at cards that have flags on it. It remembered that. And so when you come to another website, it goes out and sends the cookies to adguy.com. It goes, oh, you've been looking at advertisements for cards with flags. I'll send you more advertisements with cards that flags. Maybe that's what you want, or maybe this is what you, so it's blast you with all sorts of things. You might know if you go to Amazon and look at something that you might want to buy, you will see that ads for that stuff in the next week of your any website you go to. And that's, of course, these third-party cookies. We got the third-party cookie idea? Okay, tracking cookies. And of course, a third-party cookie is really good for keeping track of what people are doing. And you can bet that Google is doing it. By the way, yes, Google's sells advertisements. That's their business. And adguy.com, just replace that with Google. So they keep track of where you're going. They can keep track of what pages you've looked at, where you've clicked, what you searched for. And heavens, if you click on an online advertisement, that tells them you're interested in that. You're going to see a lot more ads of that sort of material. And so they know, oh, and your clicking habits. What time of the day do you visit this site? Do you look in the morning? Do you look in the evening? Do you look for your phone? Do you look for a desktop? They keep track of all these things because who knows? that may be useful. And they may be able to sell your information to somebody. Now, there are, of course, a lot of good reasons to have cookies. They provide stateless web servers the way to keep track of that user. In other words, if you go to the server, you log in, and it goes, oh, okay, I know who you are. I trust because you have the right credentials. It will then send a cookie that identifies you. Now, the cookie may just be a long string of random numbers and letters, probably a random number base 64 encoded, and it sends that off. And then when it gets it back, it can look it up and say, yes, I know who you are. You currently are logged in and you're currently doing something. So it knows where you've been, it can keep track of what pages you've looked at, whether you're authenticated, what level you are, that sort of stuff. So it allows you to look around. And imagine in a website that sells things, it can keep track of your cart and other information that it needs to know about you. And of course, what you've been looking at, so it can sell those ads later on. Cookies can also be sent to they are sent to the browser, and the browser can look at this information to see things about how it might want to display the information. What kind of presentation did you like? In other words, you can send style information telling the browser, how do you like this to be rendered? And you can save information for fields, all sorts of stuff that can be saved. I have an example here. This is a cookie I got from the North Carolina Digital Library, which, by the way, I recommend to everyone. If you have a Kindle or something, before you buy a book, go out and see if you can get it off borrow it from the North Carolina Digital Library, and you can get it downloaded to your Kindle. But you can look at this cookie here. Well, it has my email address. It says, okay, library. I typically use the Greensboro Library. My library card comes from the Greensboro Library. The North Carolina Digital Library doesn't issue library cards itself. It requires you to have a library card from a physical brick and mortar library. And then it knows about all those. It has a number here, all sorts of things. How I can check out 6 videos or 6 audiobooks or 6 ebooks. It knows I use Kindles. It's got that there, and all sorts of things. I can check things out for 28 days, that sort of stuff. So all this stuff is in the cookie. I did not experiment with changing these values. By the way, this cookie was HTML encoded. That is, several of the characters were converted to the % value encoding. I decoded it and then put it here. Now, you can find your cookies. As I looked at the cookie there are several ways that you can look at the cookies that your system is using. Of course, we all know how to use Zap now, and Zap lets you look at everything, all the headers and all the text being sent back and forth from your browser. And you can see the headers and see what cookies are included, what those values are. The curl program that runs in a terminal or command line for Windows can be used, and it returns cookies. You can even send cookies. There's a -- cookies option in curl that allows you to send cookies, and it works. I've been experimenting. So you can look at cookies that way, or if you are in the browser, go into the debugger. You can click the buttons, or Control-Shift-I gets you into the Chrome debugger. This works with almost everybody's debugger, but I use Chrome most of the time. That's what I'm familiar with. Go to the debugger and then add a watch. Look at the document.cookie variable, which of course are the cookies that are available to JavaScript. Now, if a cookie is HTML only, you will not see it, but you'll see the other cookies. And if you mouse over the name, it displays the value, which, like the previous cookie, can be kind of long. You can also right-click, copy it to the clipboard, and do whatever you want to with it from there. So you can see what cookies your computer is dealing with. Now, cookies aren't without their difficulties. They don't just identify the user, they actually identify a user computer browser combination. If you change any one of them, you got to get different cookies. If you go to a different computer, well, your cookies don't go with you. In fact, if you go to a different browser on the same computer, the same website, cookies don't follow you. Also, there's an issue with the back button. A friend of mine who does web development says, yes, the back button is the root of all evil. And if you click the back button on your browser, you go back to the previous page, but your cookies may not go back. You still have the cookie for the last cookie you got. And so you end up with an inconsistent state where your cookie thinks you're here, but you're actually looking at some other web page. That can be a difficulty. Now, cookies identify a user, and the European Union adopted the General Data Protection Regulation 4 or 5 years ago, about 5 years ago, and it restricts the use of cookies. Since you've been using computers for a while, you may have noticed, about 5 years ago, all of a sudden there was a flurry of these banners at the bottom of the web page saying, we're using cookies, click here to give us permission to use the cookies. Because they have to have your permission. Clicking there gives them permission to use the cookies. Otherwise, no cookies, because they determined that a cookie is associated with a person, what they define as a natural person. If you remember, the Supreme Court of the United States sometimes thinks corporations are persons, but natural persons are people that you might know. And they're associated with a cookie. Therefore, keeping the cookie keeps personal data about this user, and they have strict regulations about keeping personal data for privacy. The European Union has significantly stronger privacy regulations than does the United States. Now, you can stop cookies in several ways. There's usually some sort of private browsing mode available on your browser. If you're using Google Chrome, it's called the incognito mode. Microsoft Edge calls it the in private mode. Safari or your Apple system calls it the private browsing mode. Everybody calls it something different, even though it's the same thing. You've got to call it something different. Otherwise, you're violating somebody else's trademark or patent. So you do the same thing and you call it a different name. When you do that, it does not permanently store cookies or site data or forms. In other words, when you're done, there's no indication, there's no indication on your browser of what you've been looking at. So you can use that, particularly if you're sharing a computer with somebody, use that information. Okay. Your browser, whatever browser you have, also will have options about using cookies. This is the information I got from Chrome. One is allow all cookies. That allows first, second, third-party cookies. Then you can block third-party cookies in the incognito mode or the private mode. And then there's different options for blocking third-party cookies. Always block third-party cookies. So you can block third-party cookies all the time. In other words, when something goes out to get a picture, it will not use a cookie to do that. Some things won't work as well as you'd like if you don't do that, although a lot of things don't work that you don't want to work. And then there's the block all cookies. Typically, you don't want to use block all cookies because then a website does not have any connection from one page to another. In other words, things like shopping wouldn't work well because it wouldn't know what you've purchased and be able to relate that when you come back and go to pay for it, and all sorts of things. So it's just the server wouldn't have any connection between one page and another. Now, in some pages, it doesn't matter. For instance, Wikipedia doesn't really store too much about you. Actually, it does, but it doesn't look like it stores. And you could block all cookies and go out to Wikipedia and just look at one page after another. Unless, of course, you're one of these people who edits Wikipedia, in which case, well, it needs your cookies to know that you're you. All right. So that's cookies. Any questions about cookies? Anybody, everybody good with cookies? Or run off to the kitchen and get some? All right. Well, yes.
Excuse me, sir. Is this some cookies related or has connection with the emails?
I'm going to say no, although that's a possible maybe. Okay, we're not talking about security between an email server and your email client. That's a different situation, which may or may not use cookies. Probably not. Although if you have if you're using email on the browser, then certainly cookies are involved there. But just email that is, like I use Microsoft Outlook to read my email. It is not a browser-oriented program. It's an application on my desktop. And so it doesn't use cookies. But if you have Gmail, if you're looking at Gmail on the browser, which is the typical interface, then yes, there are cookies involved. Did I answer your question?
Yes, sir. Thank you so much.
Okay.
Appreciate it.
All right. Any other questions? Okay. Well, then you're probably all wondering about that exam. Let's take a look at that exam here. Hang on. I just like applications that think they own your whole computer. Okay. Whoops. Where are we? Back to, let's take a look at that. All right. We had an exam a week ago, and hopefully you've been able to look at Blackboard and see your score. Unless you got 100, I put comments for every time I thought I should take points off. So let's look at this. First of all, the grading scale. This is the undergraduate grading scale, which is just like the graduate grading scale, except it has C minuses, D plus, and Ds, and the graduates don't have that. So I just cut it off right there. So that's the grading scale. So you can see you can get down to 85 and still have an A or an A minus, but you have an A-type grade. B's go down to 75 and so forth. C is good down to 62. Below 62, well, you got some trouble. How did people do? Here are the statistics. Here's a histogram of the grades. And so you can see there were a whole bunch of A's, which I like. I like the idea of there being A's, lots of A's, A minus B's. There were some bad grades. Sad to say, some people just didn't do well. And typically, interestingly enough, people who didn't do well didn't answer most of the questions, which is, doesn't help your grade at all. For those who like statistics and numbers, that's me, the median score was 63. Oh, excuse me, 83, which means about 64% of the students got a B plus or better. That's good. About 2/3 of the students got a B plus or better. I'm happy with that. I can't get everybody. I also wondered, because this class is about half graduate students and half senior undergrads, are those undergrads any better than the graduates? The answer to that is no. There's no statistically significant difference between the two. The difference between the means is quite small, much smaller than the standard deviation. So at almost any level of statistical significance, you can't see there's any difference. I had a survey and I asked you, how long did it take you to do the exam? And there's the answers. The median score was 3. In other words, half the people took 3 hours or less to complete the exam, and half the people took more than 3 hours. I apologize to these people down here, 8, 9, 10 hours. I'm sorry. I had no intention of creating an exam that was going to take 8, 9, and 10 hours. I was thinking 2 hours, and usually I was right. That's the mode is 2 hours, which is kind of what I was aiming for. And I thought, yeah, there'd be some show-offs who do it in an hour, and some people would take 3 hours. maybe a 4 hour. I didn't expect people to take 6, 8, 9, 10 hours. And I'm sorry, I'll try to do that, do better in the future. Yes. In fact, I want to apologize for the exam. There were, as you may have noticed, multiple errors. I had this, what I thought was clever idea. It seemed like a good idea at the time that I would make a different exam for everybody and then give you a long period of time. So you could talk to other people about the exam. I didn't want you to do that. That's sort of cheating. But had you done that, I was thinking I might be able to fool you a little bit by making the exams different so that your question would not be the same as other people's questions. So if they said, well, what about that question too? And you'd go, well, I didn't get that from, that's not the question I got. And aha, so we fool you. Well, that caused a considerable number of difficulties. And then I fixed that. It caused more difficulties. And then I had typos. Comp 621 had to be capitalized. Oh, that was a mistake. I went back and capitalized it. And then I foolishly copy and pasted the 621 capitalized into every place it occurred. Well, Microsoft nicely added a space before it. That put a space in the middle of the URL and then it didn't work right. All sorts of issues. So I'm sorry. I'm going to work real hard so that doesn't happen in the future. Most people in general did pretty well because a lot of B+. I think the question that had the most difficulties was question number 1. And you probably remember this question well, was it asked, starts off, assume you have managed to insert malicious JavaScript in the response sent to a browser from a dating website. Okay, right away, you should say, that's a persistent stored cross-site scripting attack. By the way, we have been talking about cross-site scripting attacks. That was about the only attack we talked about before the exam. So you should have guessed cross-site scripting was probably going to be involved. Some people went off into the wild blue and dreamed up all sorts of solutions and problems. And then the question really was, explain somehow what the JavaScript will do. Well, some people explained what the JavaScript to do. Some people wrote me an English novel, and I got an assortment of answers, some of which were just not correct. So that was the biggest one. And then question number 2 asked about how you could get that information out to the website. It was a dating website. I realized that that's not the example used in the textbook. Although if you go out to several other websites and look up cross-site scripting, that is the example that's so often used. And maybe the order of question 1 and 2 is confusing. That was the order in which I thought of the questions. That's the order I wrote them. I probably should have reordered them. Oh well. I have some questions for you about this. Okay, let's go to polls here. All right, let's run the poll. So would you please click your answers to this? Your instructor wants to know. All right, there's a couple more people. Get out there and click, and we'll look at the answers. Okay, there's 2 of you holding up. You may have fallen asleep, I understand. That could happen. Okay, well, let's everybody take a look. Okay, there's a couple of you out there who read the textbook. I really wish you would. I appreciate your belief that I can provide you with all the information you might possibly need. I'm sorry to tell you, you're misguided. You really need to read the textbook. I sometimes read the textbook is also a pretty good answer. And then there's at least one person who says they don't even have a textbook. Come on, the textbook's not all that expensive. If you have a Kindle, you can get the Kindle version. That's what I use. And then the pre-recorded lectures that I spend so much time pre-recording. Yes, well, I was happy to see that most of you, the great bulk, what is that? Yeah, 100% of the people watched at least some of them. Yeah, I wouldn't go back and watch some of them, but I'm glad that you would. Okay, well, I'll continue to do that, and we will continue to work as we said we would. All right. So, any questions about the exam? And as always, if you think that mean old Dr. Williams misgraded my exam, well, let me know and we'll look at it. But any general questions? Justice, you look like you were clicking.
Yeah. Yes, I was. My question is actually on the first question. You said that it's a persistent attack right there. But also that it's intercepted in the response. So the response is that, so it could be two ways. It could be that the response is intercepted or done by on the server side so that it's permanent, or it could be that the response is intercepted as in it got tapped in and it's not persistent, so it doesn't stay for a very long time. So it's only for a particular client response.
I see what you're saying. It had been my intent. It does say in the first sentence that the information was already there.
It does?
Yes, as soon as you have managed to insert malicious JavaScript in the response sent to a browser. I see what you're saying. Yes. That wasn't written as precisely as perhaps it should have been. My intent, you didn't know what I was thinking. Well, you just knew what I wrote, for Pete's sakes. And if you know what I was thinking, you could answer that with more clarity. I intended it for be the classical cross-site scripting attack, where on some dating site where you answer a question, in addition to your answer, you add JavaScript. And so when another person looks at it, the JavaScript is then run on their browser.
Mm-hmm. So,
yeah, okay. If you think your answer was correct in the interpretation that you gave, send me an email and I will gladly reconsider it.
Okay, thank you.
Okay. Yeah, anytime you think maybe I was confused, or particularly some people might have been, some people I didn't understand what they were trying to tell me. You might have had the right answer there, but what the blazes is she trying to say? Ms. Brown, did you have a question?
I did. I wanted to say that because I think for my answer for that question, I put something we went over in class about how if you went to a website and, you know, somebody could put a comment in, and if they click on that comment or something, like the stuff will get saved to their browser, right?
Comment. Yes, that's right. That would be a persistent stock where you have a comment field and you type in a comment in addition to saying, I think this is wonderful. You also put in some JavaScript.
I think that's where I was going, but I don't know if
That is a classical persistent cross-site scripting attack.
Right, okay. I think I was going there, but I don't know, maybe it was.
Okay, if you think I got in a snit after reading some of these and I was just, my electronic red ink was spilling all over, send me an email and I will relook at your exam.
Okay.
Oh, and a very good question came up in the chat. Will solutions be provided? That would be nice, wouldn't it? Wouldn't it be nice if I provided solutions? Okay, I'll do that. I have solutions. Well, some of them I didn't write down in full, but the ones that were coding, oh yeah, I have. In fact, since we're done with this, when we're done with this, I'll go over some more. Okay, any more questions?
I just have a quick question about that same question, but mine is more of an explanation because I think I did get it wrong. I put persistent because I was referring to that example we did in class with somebody sending like a phishing link or something in an email with JavaScript in it.
Yes.
And I wasn't sure because that was listed under non-persistent.
Yes.
And so I was like interpreting the question like that. And I don't know if you could just explain that because I think I did interpret it wrong.
Yeah, send me an email and I'll look at yours. In a general sense, some people, the biggest thing people want to do is, for question one, is tell me how they got the the malicious information on the website, which really wasn't what the question was asking. The question was asking, what does the malicious information do? Once you got there, I should have reordered question 2 and 1, say, how do you get it out there? And then once you get it out there, what evil stuff should you have it do? Okay, well, yes. I originally thought of the first question, what would it do? And then I thought, oh, why don't I ask them how they get it out? It would be more sense. Okay. And also, if I had reordered it, I could say, well, if they did it this way, then their answer should be like that. And if they did it the other way, maybe a different answer. I would, okay. Well, yes. So let me know if I've made mistakes, or if you'd like me to reconsider your answer, which I will do gladly. I promise not to take any further points off. Okay, I will create an answer key and put that out there. And probably put it out on Blackboard and send everybody an email when it's available. All right.
Can you explain the question 2?
Question 2. All right, just a minute. Let me bring up the questions here so I can maybe show everybody the questions. All right. And I'm going to share. Okay, there's the exam. I think you've all seen that one. Ignore the name up there. That's supposed to be happening. See, this is. Oh, well, sorry, somebody's name is up there, but ignore that. I apologize. You're not, anyway, okay. Question 2, how might you get your malicious script into that exam? Well, as a dating, I simply wanted you to say, as you inputted information, comments or name, you'd also add JavaScript. That would have gotten you all the points. Some people, again, wrote paragraphs and books about something, and sometimes it looked like the answer and sometimes it didn't. Did you was that yes, husband, did you have further questions about this question? Okay, any other questions about the questions? Yes, and yeah, see, that's a little space there. That space should not have been there. Sigh. And the exam may not look like your exam because they're all individually tailored. Each one was different, which is probably a mistake. I'll try not to do again. Okay, any other questions about the exam? Email me if you thought I was unnecessarily cruel and evil, and I'll take a look. All right, well, if there's no more questions about the exam, then we'll move on to cross-site request forgeries. Hang on here. Okay, let's share the screen again, and there we are. Cross-site request forgeries. Okay. What is a cross-site request forgery, you may ask? Good question. Okay. They have other names, one-click attack. Which I don't understand one-click attack because you can do one without any clicks at all. Session writing, that makes sense. And usually I've abbreviated it generally as CSRF, which somebody thinks you ought to pronounce CSRF, which I haven't, or XSRF, where cross is abbreviated with an X instead of a C. Okay, anyway, what is it? Okay. It's basically when you submit commands from a user based on the trust of the cookie. And I like to quote, which says, unlike cross-site scripting, which exploits the trust a user has in a site, CSRF exploits the trust that the site has in the user. By the way, I go out to several places to look this stuff up. Oh, I wish that you would learn at least half as much about this stuff as I do every time I look this up. But I go out to Wikipedia, and I went out to WebGoat, and I went out to several other sites, and I've got I have a copy of the textbook and other textbooks. I look at all this stuff to see what it is. I'm really only one chapter ahead of you. And so I went out to look at this stuff. And I noticed that Wikipedia and WebGoat had word for word the same explanation, which tells us that either the WebGoat people copied from Wikipedia, or the Wikipedia people copied from WebGoat, or the person who wrote the chapter in Wikipedia is also a person involved in creation of WebGoat. Well, something like that. Anyway, they're word for word the same. So since everybody was saying it, I thought I'd put it on my slide too. Okay, what is this cross-site request forgery? Well, the basic idea. Okay, you go out and you log into your favorite social media site, whatever it is, Facebook, Twitter, blah, blah, there's zillions of them out there. Of course, as you log in and as you're using the site, your browser sends cookies to this. If you go the first time, the site sends a cookie to you. The browser then sends those cookies back. And so the server goes, oh, yes, I know. It's that Ken Williams guy. Although the Ken Williams guy doesn't use social media, so how would it know me? But, and then, so as you go to different places on the website, it knows it's still you. Now, while you have your browser open, you open up another tab in the browser and you go to another website. Or maybe you click on a link in an email, which automatically opens up another tab in the browser. And it goes to a different website from some third-party one. But that third-party website has an access to that. It can either, we'll talk about different ways you can do it. It can be a form, request, a link, image. And it goes out to the social media site and does something, gets some information, sends some information, goes out there and does something to your social media that you didn't see. In other words, this is all happening under the cover. So as you're seeing the information you wanted to see when you clicked on that third-party site, but it's sending information out to your social media site. It works because you're logged in. As long as you're logged in, you've got these cookies. The request from the other website comes from your browser, and your browser sends your cookies for that social media site. Social media site says, oh, I know who they are. I've got a cookie from that person. And so it works. Okay. Oh, sorry. My mouse is getting lost. Okay. There are some common characteristics for all of your cross-site request forgeries. First of all, it relies on that cookie. It uses the cookie to identify you, which are so often used. The cookies are sent magically between the user and the browser. The user doesn't see them. It works just fine. So the browser knows it's the site, and the site knows it's the browser. Fine. Exploits the site's trust in that. They knew that cookie. They sent that cookie to that browser. They got it back. Particularly if it was sent over an HTTPS encrypted site. Well, nobody else could have that cookie. Well, not so. That cookie is in that browser. And if that browser sends anything to that site from any other place, it will send that cookie along, because that's the rule, and it will think it came from its application. And of course, you only do this if you want to have side effects. It's no fun doing this if there's no side effects. Okay, now you may have remembered the same origin policy. We talked about this a couple weeks ago, which says that you can't do this, that a website's JavaScript cannot get data from a server other than the server of origin. And this is the server that you see in the address bar for that website. So if you go out to www.acme.com, JavaScript on that web page from Acme cannot go over to the williams.com.ncat site. The JavaScript can't, but other things can. You can get images, videos, uh, style sheets, cascading style sheets, whatever you want, or forms from the other servers. Those can get to the other servers. It's just JavaScript cannot. Here's some examples of accessing the other server. Okay, here we have an image. And the image, let's say it came from acme.com, but the image has a source and it goes to nastybad.com and passes it some parameters. In this case, the parameters are my username and my password, which of course you don't normally need to get an image, but that's okay because Nastybad will gladly send you an image if you give it your username and password. These are the username and password to some other application, but we're sending it off anyway. And so the browser makes a GET request to the server to get this file. And the GET request normally is looking, of course, in this case for an image, a JPEG or a PNG or something like that. But it doesn't have to be. You could ask for anything. And of course, if it's not a graphics file, it won't be displayed. But if you're really a sneaky system, you accept the input and always send back some appropriate picture. Here's an example. In fact, for some of you, this is the solution to one of the questions on the exam. This simple little program allows you to input a picture on the input field. Here we have a input field, and you input a text field, and then when you change, on change, whenever you change that, it calls the show name function, which is up here. In the exam, you're supposed to write this, and here is the solution. We just get the in stuff, the text that was entered. We get the element that down here we're supposed to change this. It says change this picture. Hey, we had the cow hazard. And then change that and just put the user input. So we're assuming the user input is the URL to a picture. Now, if you just typed in, several pictures like victory.jpg, there's a victory.jpg file out there, and it would download that one onto your, and it would show on the screen, just like you expect to use. But you could also type in other URLs from other systems. And I've experimented with this. Well, I can run this file from one site and look at get pages from another site or pictures from another site. In fact, I typically do my experiments where I put this on my desktop. It's just a file, and I click on it, starts the browser. No web server involved at all. And then go out to other web servers and get their pictures, and it works just fine. Questions about this? Okay. Another way to go out to another server is with a form. Now, a form, again, is not JavaScript. It's part of HTML, an HTML form. You've probably seen a couple of forms in your life. And you can fill out a form with the usual labels and buttons and all sorts of text stuff there. And you fill it out and you click the button and it will ship the stuff off to a site. Where? Well, you might think the site will go, but it can send it to anywhere. That will go to any computer in the universe. It can send it with either a GET or a POST, which is convenient because some systems only accept POSTs or only accept GETs. And so you can, here it says method equals POST. You can change that to method equals GET, or you can, if you leave it off, by the way, the default is GET. So it'll go off and do a GET and sends this off, which is actually incorrect. If you remember the rules, a GET is not supposed to change the state of the server. A GET is supposed to be a safe command, only gets information that's already there on the server. Idempotent GET. POST, on the other hand, is sending information. So it should be a POST, but yeah. Now, the field I showed here, it has a input type equals submit. That's a button. If you're unfamiliar with JavaScript, it's a button. Button says submit. You click on that button and it will send the stuff that the value that you typed in under the text my stuff. as a ID my stuff equals and whatever text you entered. Of course, that would be if you click the button. You don't have to have a button. You could make, instead of saying type equals text, you could say type equals hidden. Leave off the submit field, leave off the label field. So all it is type equals hidden, ID equals stuff, name equals, and you might put a little, some JavaScript to create that value. Okay. And then with JavaScript, you can do a submit command to that form element. In other words, you find this element in your HTTP with any way you want to do a find, get element by ID. This one doesn't have an ID, but we can put it on it. Or document.forms gives you a array of forms, and this may be the only one, so it's forms bracket 0. Anyway, you get that, and you just call dot submit parentheses the function on it, and it will submit it for you. So if you have a form out there with no input fields, hidden text, and it's submitted by JavaScript, even though JavaScript can't send the information, JavaScript can initiate a form, and the form can send information. So nobody's safe. All right. Questions? Got that? Oh, my mouse has got weird. Oh, there we are. Sorry. Okay. I've been experimenting with this. Now, from my experiments, if I used the image, like the changing the picture, when it sent out a GET request to the server, it never sent a cookie. Cookies weren't sent. Well, if I used a form request, it did send a cookie. And of course, if I just typed in the URL in the address field, it did send a cookie. And cookies are shared from different websites as long as you're in the same browser. In other words, if you're in the browser under one tab and you've got another tab, and the other tab sends a request to the server of the first tab, then it will send the cookies. And that's the whole problem. The cookies are sent, you get it. Now, if you start up different windows of the browser, in other words, I have 2 windows of Chrome open, they don't interact. 2 tabs within one window of the browser interact. And of course, if you have an instance of Chrome open, you have an instance of Edge or an instance of Safari open, they don't talk to each other either. So they don't share the cookie information. Okay. Email can contain links. I often get links in email. It's interesting to note that what the link says and what the URL that it will go to do not have to connect in any way. Of course, often these days, the link just has some English, like click here. Often they have the word here. Well, but it may not be there. Particularly what's really sneaky and mean and bad and nasty is when the text will say something like www.warmandfuzzy.com. But that's not the link connected to that. Instead, that's just text. When you click on that link in the email, it goes to a different website. For instance, my example of spiders and snakes. So you click on one thinking you're going to go to warmandfuzzy.com. No, it goes to spiders and snakes, which might tell you, by the way, personal safety. One of the things you can do in your email is most email systems, if your mouse hovers over the link, you will someplace see what the URL is of it's going to go to. The email that I use, down in the lower left-hand corner, it shows the URL connected with that link. Where is it going to go? So if I put the mouse over warm and fuzzy and look down in the corner, it says spiders and snakes. I go, oh, that's not good. Now, what always works safely is you can copy the word www.warmandfuzzy.com, paste it into the link of a browser, and it will go to warmandfuzzy.com and not to spiders and snakes. Okay. So you have to be aware of that. And of course, since this is a class on web security, that's how to protect against it. But I'm also telling you how to be mean and nasty and attack that way. But remember, it is not the purpose of our class to teach you how to be mean and nasty. The purpose is to teach you how to prevent people from being mean and nasty. There are several ways you can protect a system against cross-site request forgeries. We'll talk about frameworks and non-cookie tokens. I mentioned same-site cookie option. That's where you can say same site equals strict, same site equals lax, or same site equals none. And again, same site equals strict prevents cookies from going to other sites. So I'm not going to take any more about that. You can just go back and look at the previous. Oh, I forgot to post the slides today. Well, you can't go out, but when the slides are out, you can go back and look at the previous slides. I'm sorry. All right, let's talk about these in some more detail. There are several frameworks that you might be using for your web server. These are server-side protections for cross-site request forgeries. And there are several of them, depending, of course, on what system you're using on your server. If you're running Java servlets, then Spring Security is one system. OWASP has its own system. OWASP also has a system for Apache and PHP. That's, by the way, PHP and Apache is what I'm using on my site, which you could have been able to figure out if you looked. If you're using JavaScript, Angular JavaScript to run your server, and again, you can have you can have JavaScript on the server as well as running JavaScript in the browser. But if your server is running JavaScript, and I pity you if it is, but if it is running JavaScript, AngularJS has a cross-site request forgery protection, as does the Microsoft.NET. I haven't talked about Microsoft.NET, but that's a distributed system, and it has built-in protection for cross-site request forgeries. It is always better to use a well-designed, well-implemented existing system instead of creating your own. Unless for some reason you don't think theirs works and you have to create your own because you're doing something different, weird, I would use somebody else's system. Now, one of the ways they do this is they add tokens that are not cookies. In other words, the cookies, the problem is that with cross-site request forgeries, that cookies are assumed to identify the user, but not always. Well, they identify the user, but not in the right place. So they add additional identifiers for the user in addition to cookies. They create some sort of token. Typically, the token is just a random number, but they create a token and they send it off to the user, and then the token can be used, can be sent back. And you never, ever, ever put these tokens in with the cookies. In other words, they are used independently of the cookies. So the cookies are still used, but in addition to the cookies, you have another identifier that's sent back, typically sent in hidden fields of forms or any other link to that site. You'll put a hidden field that contains the token to identify yourself. Now, the tokens are generated by the server, and they can be saved in the server's storage. And when the server gets your a second request or a follow-on request, it looks at your token and compares to the token it has saved for that user. And of course, if it's not the same, if you don't have the same token or the token's missing, it rejects the request. And depending on how bad the attack looks, you might probably want to log it, inform somebody that something's happening. Now, in this instance, we're saving the tokens on the server, which kind of violates the concept that that servers are stateless. If you want your server to remain stateless, instead of creating a token for the user, you can take some information that you always have, say a session ID. Say you've got the cookie out there and the cookie's always creating a session ID. So you take that session ID, you can hash it or encrypt it some way to create a value based on that session ID, and then take that hash, or particularly encrypted hash, and send that back as the token. And so when you get another request from this user, they should send you that token, and you take their session ID, hash it, decrypt it and go, it matches or it doesn't match. So the user's browser doesn't know how you're creating that token. To them, it's just a bunch of random numbers, usually base 64 encoded. And so a bunch of bytes that they send, you send back. But this way, if you use the hashing and encryption, you don't have to save the tokens that you've created for each user. Instead, you just take the session ID, hash it up, and that's what's used the token. The browser or nobody else can figure out what it is. They don't know what your encryption key is, so they can't create that. Hashes are one way, so they can't go back. So they get a bunch of bytes and they use it as you would as if it was saved. Just all it is the means of keeping the server from having to save additional information. Okay, so that's one way of avoiding cross-site request forgeries. Another way is to look at a couple of the other fields you'll find in a HTTP header. HTTP header may or may not have two additional fields that we do. One is origin. Origin is used by posts. It says, where did this come from? For instance, if I have a web form on one site that sends the results to a second site, the origin will specify the first site. So if I go to www.acme.com and it sends information to www.friendly.com, but the origin will be acme.com. But where, from what server did this request come from? Or it actually doesn't come from exactly from the server. What server generated sent the HTML that the browser then initiated the request? So it's just, where was this? Now, typically, of course, on a safe website, that the only place these should be coming from is your site, or it's the site that's in the address bar should be the site that's the origin. If it's not, and it's your server, something's wrong, and you probably want to reject the request. So that's origin. Now, you only see origin on posts, not on gets. On almost all requests, you can see refer. And refer says, where did you get this? Who sent you here? You often see this. For instance, if you have a website that has pictures on other, or has a bunch of graphics, and it's going to go out and get those graphics from the site. The HTTP requesting those graphics will have a refer, and it will tell you, where did this web page come from that asked for this information? Now, if it's your website and all the pictures are supposed to be on your website, then the referrer should be your website. If it's somebody else, then you got to decide whether you want to accept that or not. Somebody else looking at your pictures, which may be fine. Maybe you don't care if somebody else wants to look at your pictures, or maybe nobody else is supposed to be seeing this, and we're not going to let that happen. I might point out that the refer will be null if you type the address in. In other words, if you typed in www.acme.com on the address bar of your browser, and it sends off request to acme.com, the refer field will be null in that HTTP request because there is no refer. Okay, so that's refer. So and it's basically for a website, if everything's supposed to be coming from your website and the origin and or the refer are not your website, then you probably don't want to accept the request. All right, so that's all I have to say about cross-site request forgeries. Any questions about the topic? Well, next time, a week from today, I'm going to reorder some of the material in the order of information in the syllabus was the order of information in the textbook. And the author prides himself greatly in ordering everything in the order he thought was appropriate. But I think SQL injection follows cross-site scripting and cross-site request forgeries better than XML external entities. So we're going to switch the order. Next week, March 9th, we're going to be doing SQL injection, and we won't come back to XML entity until the week after that, which would be March 16th. So please read sections 13 and 25 of the textbook. And those of you that, whoever it is out there who doesn't have the textbook, and it's an anonymous survey, so I don't know who you are, I'll just track you down. But get yourself a book and read those sections, because you just can't expect to catch all this stuff from me. And I'll have some pre-recorded lectures. Since you seem to look at that, great. I'll put the pre-recorded lectures. I'll have one in general about SQL, and I'll have some others about, I know I've got one coming up on transfer security layer. So that's coming up. Oh, okay. So that's all for today. Anybody have some questions? I will put the slides for this lecture out on the website promptly. I apologize. I like to get them out there ahead of time. Somehow that didn't happen. I will try to remember to do it early. If nobody else has questions, we're done for today. See you next time.
Bye. Thank you.
Okay.
See you, Dr. Williams.
Good.